Ooh. I thought I did this already. Hi. Okay, so I gotta do this. Holy cow. Um, Hello. Welcome. My name is Lynette. We are learning how to read the abacus. When we do this, this is 1. So what is this? We are learning how to read the abacus. When we read the abacus, we're going to be able to add, subtract, multiply, and divide. So when we look, this is 0. The beads that are touching this horizontal bar is what's being counted. So if you notice, none of the beads are being counted. So none of the beads are touching the horizontal bar. When I do 1, this is what 1 looks like. This is easy. What are we doing? Yes, this is super easy. Now if you look, what we're doing is we're trying to understand what these beads mean. So that's what this is. So we have 1, and then here's 2. That's easy, right? 2. 2? Oh, remove. Okay, so I just need to remove that and then save the changes. So this is 2. Notice it's the 2 bottom beads that touch the beam. This is the beam, this is the horizontal bar. And you may be wondering, like, why am I here in the middle? I'm kind of here in the middle because there's this indicator. These are my ones indicator, right? So with my ones indicator, I am just trying to what? I am trying to count. So when I have 2, this is 3. So notice I have 3. There's a 3 bottom beads that touch the beam. That's what's being counted. So this is 3. Hello. Math is hard. Stinky. You're so stinky. Math is hard. But you know what? Abacus makes it easy. Oh, crap. Math makes it easy. I'm sorry, Abacus makes it easy. So what we're going to do is we're looking at it, right? We're looking at the numbers. And what are we trying to do? We're just doing arithmetic. So in this one, I'm only teaching you how to add, subtract, multiply, and divide. Thank you so much for the hearts. Thank you so much for the hearts. So again, what we're doing is math is hard. Math is hard. But I'm hoping that Abacus makes it easy for you guys, right? So what we're doing is we're looking at how to read the abacus. The first thing we need to do is understand how to read the abacus. And now we might be wondering, well, if this is 4, what happened to 5? 5 will always be the top bead. 5 will always be the top bead. Why is 5 always? That's just the way it is. That's just the way it is. 5 will always be the top bead. So then, guess what? After 5, we have 6. Notice how we have 1. When I have 1, right? It looks like this. That's what 1 looks like. But then what happens? When I add the 5, now we have 6. So if you notice, we have 6. We have 2. If I have 2 here and I add the 5, now I have 7. Does that make sense? So what are we doing? Here we are. I am trying. Oh, this is the wrong one. Oh boy. Oh boy. Sorry. Okay, so what do? We have 8. No, we don't have 8. This is 3. This is 3, right? We have it. The 3 bottom beads, and they're touching the horizontal bar. This is 3. So what's going to happen is when I add the 5, now we have 8. Does that make sense? I'm hoping that's okay. So what's going to happen? Yeah. So the last one make yes. Thank you. Yeah. Thank you. Yeah. So we have 4. And then we add the 5. Now we have 9. Well, okay, well, what happens after 9? Well, after 9, we have place values. Every column is a place value. Do you see that? So when we look, we have our ones, our tens, our hundreds, our thousands. When we have it, 9, then we have 10. Wait a minute, that looks very familiar, doesn't it? Yes, it does, because this and this, just like how we write. Well, I need to find my... Just like how we write. We have 1 or we have 10. We just have to pay attention to the 0. That's all it is. Make sense? How are we doing? Are we all right? Yes, I know math is hard, but I'm hoping that Abacus will make it easy for you guys. What we're going to do is we're going to add, subtract, multiply, and divide. I don't know if we're going to go all the way there, but we're going to first understand how to read the beads and then move the beads. Hey, Jose, welcome back! How are you doing? I'm sorry for last night. Last night was kind of crazy. There were so many people. Oh my God, there's so many people here. Oh yeah, I understand now. Yeah! I'm saying your name. Yeah! So it's easy, right? So what we're doing is we're learning to see and physically look at the numbers. When we look at the numbers, then we'll go into adding and subtracting. It was fun though. Oh yeah, I had such a long weekend. Yeah. Oh yeah. I hope you spent some time with your mother-in-law, mother. It is easy, to be honest. It is easy. Thank you. Yeah. Yeah. So we have 11. Notice it's 1 and 1, right? That's what 11 looks like. It's one bead here and one bead here. One bead on the ones, one bead on the tens. That's what 11 is. So when we look, guess what 12 is? 12 is easy. That's 12. And then we can just start counting. 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Looks very familiar, doesn't it? So when we look, this is 20. 30, 40. Now we can count by tens. 30, 40, 50. Always the top bead, no matter what, will be a value of, will always be a value of 5. So if I did this, this is all 5. So I'm going to write 5, 5, 5, 5, 5, 0.55. That's what that looks like. Make sense? Easy? Yeah, it's not hard. I'm telling you. Oh, I'm telling you. It's not hard. So what are we doing? What are we doing? Okay, we're going to continue on. We're going to continue on. So when we look, right, I'm going to zero it out. Thank you so much for the likes. So when we look, 9, 9, 9, 9. These are all 9s. Same thing. Just like this, now they're all 9. And we could do the same thing. So what's the question? Well, the question would be, why am I here? Well, just like a Pokemon, you need to...
Come on, I choose you.
You need to choose one. You need to choose one. Hey, Emily, I never knew I wanted to learn it. Emily, that's so funny. So yes, so if you look, I have 2 dots, right? So choose one. You can't do 2. You got to choose one. So you could choose this one or you could choose this one. It is up to you. So this time, I decided to choose...
Okay, Charizard, I choose you!
I choose this one. Why? Because now I have more beads to go all the way across. I have more digits. Ones, tens, thousands, hundreds, 10,000s. If I choose this one over here, then it would only be tens and ones and tens. And then I have no more room for the hundreds, and I have no more room for the thousands. But I have all of this to be my decimals. Does that make sense? How does that work? Is that all right? So when we look, we have our ones and our tenths and our hundreds. Every decimal sits between the ones and the tenths. Yeah. I'm just saying your name. That's a funny name, yeah? Because I say that a lot. Yeah. All right. Now, we're going to continue on. Thank you so much for liking the live. Thank you so much for coming in and talking, because I'm now don't feel like I am by myself. All right. So the first thing we're going to do is understand that we're moving the beads. We want to be gentle, right? It's not delicate, right? But we want to be gentle, right? We want to be gentle. Why? Because when we look, we want to be able to just move the top bead. If you notice that the edges of the beads are the top bead, no matter how big and fat and burly your fingers are, no matter how pudgy your fingers are, you should be able to move the beads. This is a standard size abacus, right? So if I look, they might have like really pretty colors, but it's a standard size abacus. Notice I have this one and this one. This is a regular one. The only reason why it's regular because it's got the same colors. Wow! How do you do subtraction? Oh, we're almost there. But the first thing I need to do is I need to tell you how to use the abacus, right? So what we're going to do is we're going to be moving the beads. We want to be happy and move your beads, right? So when we do it, the other thing is like say I have my number, right? I have my number and I wanted to add another number. When I add another number, don't flick too hard.
And flick. Flick too hard, damn it!
Because what happens is your answers will become all messed up. See how I flick too hard? So when you do it, you'd make sure you don't flick too hard. And I'm just moving the one bead, but because I flick too hard, everything is all connected. So when you look at it, make sure you don't flick too hard. And then the other thing is it's very easy to move. So even if you bump it a little bit, your answers will be wrong. So when that happens, make sure you use your left hand to stabilize your abacus. So yeah is ready for subtraction. So we know how to remove the beads. Anybody have any questions before we continue on? before I continue on, how are we doing? Are we all right? I am going to start going into how do we add and subtract. We ready? Are we ready? Okay. So the first thing we're going to do is I need a refresher on the abacus. Oh, hey. Oh, hell. Okay, yes. I'll just call you O. So thank you so much for the question. So what we're going to do is we're going to review what the abacus is. When we read it, we have one. Notice all the bottom beads has a value of 1. So it'd be just like I did this. It's been years since I've seen one of these. Of course, it's an older person. Of course, because I don't know what that means. It's been so long since I've used one. I love it. Oh, of course, because we all know the old math. Not relying on techno. All right, so this is 1. This is a value of 1. If you don't know, I don't know where you are in the world, but this is a penny. This penny is worth 1 cent in America. This is 1 cent. So the idea here is to know that this is 1. So when I have 2, I have 2, right? All the lower beads has a value of 1. So when I put the two together, like they're holding hands, right? They're in contact with each other. This is now we consider 2. They're being counted. If I have that, this is 3. Now we have 3 on the abacus because the beads are touching this horizontal bar. But, meta, I don't know the slide rule. Just saying. Right? No, we're not talking about dollars, yeah? We're talking about the numbers here, right? So this is 1, 2, 3. 1, 2, 3 cents, right? This one here, so you don't go left to right. We do go left to right. We talk just like we write. So if I do 4, oh, that's not 4. This is 4. That's 4. Yeah. So then, something else you can learn, we always learn stuff. No, I teach abacus and abacus only. It's been difficult teaching everybody how to do the abacus. So this is 4. All the top bead will be the value of 5. So if you do that, that's the value of 5. When we look at it, right, the top bead will always be the value of 5. When we have it, then we want to do 6. I have 6. And then 7, there's 7. And then 8, there's 8. And then 9, then, what is it? There's 9. Yeah? Does that make sense? So, Ray asked from left to right. Yeah, left to right. When I look at it, I have my 1s. After my 1s, what's after 9 is 10. 10 is 1. 1 and a 0. 1, 0. Just as we write. So abacus mimics the way we write. 1, 2, there we go. When we look, we have 11. When we have 11, it looks like 1 and 1. Right? 1 bead here, 1 bead here. When we have it, we have 2. 1 bead here, and then 2 here. 1 and 2, 12. Easy? Makes sense? So when we talk about it, we have 13, 14, and then 15. After 15, we have 16, 17, 18, 19, and then 20. How are we doing? Anybody have any questions? So what we're doing is we're learning how to read the abacus. When we understand how to read the abacus, we'll be able to add, subtract. I was confused because I didn't know that there was a decimal point there. Oh, yeah. So the decimal point sits between the 1s and the tenths, just like how we write. So if I did $1.10, $1.10. So it'd be $1.10, right? That's what that looks like. Oh, sorry, I did that wrong. $1.10. When we look at it, why am I here? I choose this one. Hey, Beals, welcome back. So the dot is choose where you start. Yes, exactly. So if I choose this one, just like a Pokemon.
Pokemon, I choose you!
Good morning. Good morning, Beal. Because I have here, I'm choosing this one. When I look at it, I could choose this one, but then I'd just be moving everything over. Does that make sense? So this is my 1's label. This is a label. This 1's label helps me understand where I'm going to place my digits, right? So it doesn't matter. Thank you, Cross. So it doesn't matter, which indicator, which label you choose, right? Just like a Pokemon. I could do this one. So this is a 7-column one. This is a 13-column abacus. With the 13-column abacus, notice that there's many more, I don't even know that's a sentence. There's more dots. So you just need to...
Okay, Charizard, I choose you!
Okay, so if I want this one, I can choose this one as my 1s. If I do this one as my ones, look, if you notice, every grouping, right, is a separator, is a comma. So if my ones, my thousands, my millions, my billions, my trillions. So when I label it, it looks like that. I have my ones, my thousands. Notice that there's a dot here. Then there's another dot here. This is my millions. After my millions is billions. After billions is trillions. I didn't see the dots in the metal rods. Now I'm understanding now. This is cool. Yeah. Thank you, Ray. Yeah. Of course. Not a problem. Not a problem. So then, because I chose...
Pokemon, I choose you!
Because I choose this one, right, I'm going to move everything over. And now I have all of this to be my decimals, or I have all of this. But if you want to track the national debt, because this is only 13 columns, you would have to get a bigger abacus. Hey, Goya. Now I don't remember. Oh, I don't know what you don't remember. I used to use... Hey, so I wonder, Goya, did you use a 2 and 5 or a 1 and 4? Okay, so if you look, this is 23 columns, and now we can track the national debt. But that's a little difficult. Notice, though, this one is made out of... this one is made out of what? This one is made out of... No, this one is made out of bamboo. Where is my... This one's made out of bamboo. Oh, no. Where did it go? Oh, boo. No. Oh, I'm sorry. I'm trying to find my shop. Shop. S-H-O-P. There we go. Oh, did I not do it? Console. Oh, I did do it. Oh, okay, good. I did do it. Okay, good. So, I'm doing this one. So, okay. How are we doing? Do we understand? We're okay? So, oh, I'm sorry. There's only 4 wood per prong. How would you represent 9 per digit? Hey, Jacer. Hold on, just honestly, I didn't see I'm just checking the comments. Oh my gosh. Oh, there's a decimal. Good morning. Na 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 na. Okay, Jacer. Okay, yes. So this is made out of bamboo. Now the bamboo is the same, and this is made out of plastic. I'm going to do this one. So Jacer, yes, thank you. Hey, goggles. Yeah, goggles. So, Jacer, you're right. We did 1, 2, 3, 4. 1, 2, 3, 4. But now the top bead will always be a value of 5. So just as I have the top bead is a value of 5, then we could do 6, 7, 8, 9. 6, 7, 8, 9. Does that make sense? Thank you. Goggles. Welcome back. So when we look, we have 9. 9, 9, 9, 9. That doesn't matter. They're all 9. When we look at it, right, we have 9. Then what's after 9? Just as how we write, we have 10. 10 is a 0, so it'll be 0 on this column, and then in this digit, and then 1 over here. I hope that makes sense. Did that make sense? Oh, I did not mean to send whatever I sent. How do you do 16? 16. Easy. Whoever is 16 years old that's what it looks like on the abacus. 16. What's the significance of an abacus? Is it like a mechanical? It's actually a counting tool. An abacus is actually just a counting tool, if that helps. So it just tracks our number, and then there's a whole methodology. So you can actually add, subtract, multiply, and divide. But you do it all in your head. The only thing that the abacus does, that this thing does, moving the beads, is it tracks your numbers. So when we look, we could do 4 plus 5, and that's like 9. That's like easy, right? And so what we're trying to do is, I'm trying to show how to read the abacus. After we learn how to read the abacus, oh wow, thank you guys for the rose and the heart me. Blushing Martha, thank you so much. Okay, so what we're trying to do is we're trying to understand how to read the abacus. After we read the abacus, we can start doing some adding, subtracting. How long does it take to master one using the first fingers instead of... Where one can use their fingers instead of the abacus. You can use your fingers. Yeah, like writing it down like tally marks. Kind of like tally marks, but it's more like just digits. Just physical representation of the numbers, right? So you could do the tally marks of 90. That's like a lot. Right? Oh my gosh. So let's do 90. Let's do tally marks of 90. I mean, do you want me to do that? So we could do 90, not a problem. Oh, maybe I should do this one, right? But it's not tally marks because 90 is a 10 digit. So that's 90. You could do 100. That's 100 tally marks, right? So it's not really writing it down. It's more like similar. Everything is similar. So if I did 100, right, I'd be like 1, 2, 3, 4, 5. I'm not going to do that for 100 times. Right? So, how long does it take to master? A couple of weeks? It depends on how much you practice too, right? So, yeah, and that's the thing. Like a lot of people try to talk about it, but it's really versatile. Like it really goes to bigger numbers. And if you notice, just as I had before, we can go all the way to 10,000. Huh. And it'll be easy. 10,000. It'll be easy. Hey, Eli. I don't have kids, but I'm happy to learn something new. Thank you. Yeah, not a problem. It's when you have kids or if you want to teach kids, hopefully you will learn to teach the kids abacus because it's the greatest thing next to sliced bread. So what are we going to do? Okay, we're going to let's do a maze. Are we ready for a maze? So what is this? This is more about learning how to read the abacus. This is really cool. I love learning. My brain just like a sponge. Oh, fantastic. I'm so confused. Oh, missed. I'm not a master, but it's like 3 weeks and I understood it enough. Yeah, right? Right, Beal? Yeah. Okay, so missed. Last year I learned binary engineering counting. Now I'm learning. Okay, so what are we going to do? Missed. 1, 2, 3, 4. When we look at it, the horizontal bar is what counts the beads. So we have 4 on the abacus. When we have 4 and we need to do more than 4, we have this value at the top bead. The top bead is a value of 5. We have 5, 6, 7, 8, 9. I don't know if Miss is still here. So after 9, we have 10. Notice that we have 0 and 1. Just as we did this is 1. How do I know? Because oh, good, you're still here. Thank you for commenting. So I chose, just like a Pokemon.
Okay, Charizard, I choose you!
What I'm choosing is I'm choosing this dot. This, if you notice, there's a dot right here. This is my ones indicator. I could choose this one, but I chose this one because then I have bigger numbers. So when I look, I am choosing this one. When I have it, hi, Beals, thank you so much for the galaxy. Thank you so much for the galaxy. We have the value of 5. This will always be 5. So we have 5, 6, 7, 8, 9. Oh, and then we're at 10. So 10 is 1, 0, and a 1. 0 and a 1. Thank you for the follow. 0 and 1. So when I look, this is 1 and 1. Does that make sense? 1 and 1. What you gonna do? Oh, happy and you know it. Be happy and you know it. Okay, I gotta find that one. So, does that make sense, Mist? So when we count it, this is 12, 13, 14, and then 15, 16, 17, and then look at it here. This is 20. 2 and a 0. 20, 21, 22, 23, 24. Make sense? So we have 25. This will always be 5. So if I did this, this will all be 5. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. I could do 9. 9, 9, 9, 9, 9, 9, 9. These are all 9s, right? Make sense? Oh, thank you, advanced celery. Oh, I love celery. I don't get it. Oh, I don't know what you don't get. I just counted. All right. So what are we going to do? When we look, we have 1, 2, 3, 4. Make sense? Oh, that was the thing that I wanted to do. So when we're working with the abacus, you want to make sure that you want to be gentle. It's not delicate, right? This is made out of plastic, so it doesn't matter. You don't want to be aggressive. Don't be aggressive. Don't be aggressive. You want to be gentle. You can't go above 99, Nate. Oh, you can, but not on this one, because this is only 7 columns, right? If this is only 7 columns, you can only go to 99, 999. However, if I want to go higher, because size matters, I can do 13 columns. Right? And I can do trillions now. So if I choose this one to be my ones, I could do trillions. So I make ones, thousands, millions, billions, trillions. But if I want to track the national debt, this is not big enough. What do? Is I have to find a bigger abacus. My bigger abacus is a 23 column one. So my 23 column one, because size matters, it just tracks it. And I can track the national debt. This is made out of plastic. I'm sorry, this is made out of bamboo. But notice, all the beads are very easy to move. So be careful. Don't flick too hard. Don't flick too hard.
And flick. Oh, you flick too hard, damn it!
So all my answer is 5 right now, right? 5, 5, 5, 5, 5. And if I did this, notice that now I flicked too hard. My answer is now wrong. I wish I could understand this, carrying it everywhere. Ha ha ha! Bebop. Ha ha ha! Right, Martha? So don't flick too hard. Oh, sorry. Don't flick too hard. Okay, we did this, we did that. Oh, make sure you hold the abacus because it's very easy. If you bump it, right, your answer will be gone as well. So it's very easy to move. And this is a standard size abacus. So no matter how big and burly and pudgy your fingers are, you should be able to still move the beads because you want to use the tips of your fingers, right? The tips of your fingers. The edges of the beads is where you're touching to move the beads, right? So this is being gentle and happy. Be happy when you do abacus. Be happy when you do math. Right? You don't want to be aggressive and start pitching it down because it doesn't help anywhere. All right. So we're okay with that? Anybody have any more questions? Thank you, Martha. Right? Funny. Thank you. I have more sound bites. It just depends on how far I get. All right. How are we doing? What's going on? Thank you so much for the rose. Revlis. What? Too easy. Eric. 3,224. Brr. I like math, but I never got too far. Oh, yeah. No, angry math. Yeah. Can you show as an example of counting a larger number? Yeah. So, who is it? Eric provided 3,224, right? So we could do 2025. This is the year. We can do 9,325. So exactly how we write it is exactly what we see. So we have a 9 is the 9,000, right? 320 and 5. Cool? Oh, cool. L Bean. How does this work? Yeah, makes sense? Misty, are you still any other questions? So, thank you for asking, L Bean. Okay. 10,000. So we have 10,000, 0, 9, 1, 1, and I'll do one more. 0.35. Ha 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 ha. This is actually way more simple than it looks. Yeah, right? So when I modified Eric's, so we did 10,911.35. This is the first time I'm watching TikTok use just stories. That's fantastic. Thank you. Thank you, Eric. That's the it's so easy. I'm telling you, it's really easy. But you look at the numbers. When we look at it, I don't know if L Bean is still here. Notice we do 1, 2, 3, 4. And it doesn't matter. 4, 4, 4, 4, 4. These are all 4s. When we look, right, we have 5. 5, 5, 5, 5, 5. It doesn't matter which one it is. It just matters on the place value. Just like how we write. And then we do 6. We have 5, 6. 6, 6, 6, 6. Right? If we do, this is 0. Anything touching the horizontal bar is being counted. So we have 6, 7. 7, 7, 7, 7, 7, 7, 7. Those are all 7s. If I remove it, and this is now 0, do you teach a full course? I do teach a full course. I have also workbooks too. So if you're looking for children to learn the abacus, I have workbooks. And this is available also on my TikTok shop or here. It is up to you guys. I picked this up in 5 minutes. I think it's very simple. I want one now. This is cool. I've never seen anything like it. I love learning new stuff. Yeah, first time I've seen yours. I've taken classes before. Hey, Sarah, that's fantastic. What kind of classes did you take? The abacus ones? And how boring was it? Because I pride myself on not being boring. we've got jokes, right? It was so boring. I know. I feel sorry for my kids. I have 3 boys. They all gone through the abacus, and it was so boring. But I'm trying to make it more interactive, and that's why I'm trying to do all these activities. So I have all these activities. If you notice, here is another book that I have created. It's called the Abacus Maze, and this Abacus Maze is it's bead recognition. So here we do bead recognition. Oh, thank you so much. So this is bead recognition. What we're doing is we're looking the maze. I haven't done it. I got to do the 3-digit and I got to do the 4-digit. I've already done my one of the books, and so I'm continuing on. So the 2nd digit. So this, if anybody can tell me what number do we think this is? What we're doing is we're looking at this maze. So this is about I've taken classes before. Yeah. Thank you, Ray. So what we're doing, what number is this? How do we know what number this is? Let me know in the chat what number this is. If we do this and we do, wah! Sarah. I hope that was a fat thumb thing. Sarah. Yes, exactly. It's 15. It is 15. So because I know the number here, it will tell me which path I'm going. So I'm going to go over here and it takes me to here. So what number is this? 65? No, not 65. How do we get 65? So we get 60, 5, 6, and then this is 5. What I showed was 15. 1 and a 5. 24. Yes, 24. How do I know? Because we have 2 here, we have 2 here, and they have 4. 1, 2, 3, 4. 1, 2, 3, 4. We're big people, so we're going to do one big one like this, right? So notice I am adding to the horizontal bar. When I subtract, I want to move it away from the horizontal bar. So what we're doing is we're learning how to read the abacus and going through my maze, because I like puzzles and I like mazes. So when we look at it, what number do we think this is? If I have this number, we're at the 10s, and then we have this. Hi, hey Cam, welcome back. So this and this. Word right now is 72. Yes, 72. Make sense? Thank you so much. Okay, so we're going to continue on. So this is the book. The book is about bead recognition, and we're only doing 2-digit. And then I have, when you get used to using the abacus, lots of people don't need to use it. They just use imaginary. Yeah, they do. But my kids, I didn't push them to do imaginary because I just, they have other things to do. So you could teach them to continue to do imaginary, but I didn't push it. So my next one is called a reverse maze. What it is you see the number and then you have to color in the beads. So that's what that means. So this is my, thank you for the follow, Sarah. So this is the reverse maze. And with my reverse maze, you have the number and you have to color in the beads. And so here is 96. I'm going to color in the beads. And I actually made it different. I modified it. So there's a little bit of a typo. And then this is 29, so I go here, and then this is 29. If you notice, I go here, I have to color in 17 beads, right? How to make 17 here. And that's what I did. That is my maze. So the only thing you're doing here is there's like 14, 24, something amount of mazes. I don't remember. And then there's answer sheets. Just in case you don't know, I got answer sheets. I got answers. So that's what my maze is. So the first thing you need to do is understand how to read the abacus. That's what this is. The next thing we're going to do is we're going to understand how to move the beads. Oh, okay, here we go. So the first thing we're going to do is understand in the abacus world, because
this is the way.
This is the way. This is the way.
This is the way. We are going to look at the add-in and not the result. We're going to focus on the add-in. We're not going to focus on the result. So no, because in abacus world we have more than just 2 lines of add-ins, but in regular school they only do 2. So it's easy to know what the numbers are, right? It's easy to know what the result is. However, we don't want to we want to divorce the result and marry the process. So the process is learning the add-in. Do we have enough? So here's my question. I want to add the 5. When I add the 5, I have enough, right? And then my next one is, can I add the 1? Do I have enough to add the 1? Is there enough? Can we do it?
Yes, we can.
Yes, we can add the 1. So when we add the 1, we're just moving the 1 bead up, right? So when we're looking at it, we're making sure we understand how to move the beads. So here is 7. If I have 7 and I want to add 1 bead, do I have enough? Yes, so we have 1 more bead and we add it. Does that make sense? So what we're doing is I'm showing you how to move the beads. When we add, we want to go to the horizontal bar. When we subtract, we go away from the horizontal bar. As we move forward and we move backwards, right, you will see that it's very common, very similar, right? If we know how to add, we will know how to subtract. So we know how to add the 1, we know how to subtract the 1. Now we have 2. Again, what we're doing is we're noticing our add-in. We need to focus on our add-in. We're focusing on our add-in. When we have we have 6. As we do 6, is there enough beads to add the 2? Yes, there's enough to add the 2. So I'm going to add the 2. Just use a calculator or you head. When is this thing needed? Chase, if you had proper English, it'd be easier for you to understand. Obviously, it's for children. Or it's for big people. It's for people that are open to understanding new things. If you don't want to learn, that's fine. You can move on. That's up to you. However, I am teaching a new skill. It's like learning Sudoku. How do people learn Sudoku? Or crossword puzzles. Why don't you just use Google for your crossword puzzles? Or what? Sudoku. I don't know. It's helpful, right? Thank you, Beal. Thank you. It's very helpful. It's the fun grade. Oh, yeah, that was a funny thing. What grade is this for? It's the fun grade. It's for the fun grade. So here, we know how to add the 2. Well, that's fine. But notice we're not focusing on the result. You say 2, but sorry. 2, there's 6, and then there's 2. 1, 2, and I add 2. Could you explain that for me, please? Sorry, that was mine. She's low-key AI. It's only been around for thousands of years. I need this book. Oh, my 7-year-old. Oh, hey. Oh, you know what? The abacus, yes. However, there is this one called the Kramer abacus. If she is blind, I would suggest using the Kramer... Kramer abacus. Kramer abacus. You know why? Because it's stiffer. So this one, yes, she had that one. Oh, so then you should be able to do this one. Oh, so yeah, the book. So yes, but you would have to explain it to her, because I wouldn't know how to. Sorry, I'm trying to fix my keyboard. I accidentally. Okay. I'm trying to fix my. There we go. Is that working? No, that doesn't work. Okay, sorry. Okay, sorry. You know what? F. Screw it. I'm gonna have to work without spaces. Okay, so she has the stage red one typo. Oh, this is the first time I've seen the educational on TikTok. She has the red one. The red one. I don't know the red one. I only know of it, and I know that it's stiffer. So that was really interesting. Oh, I'm gonna move that. There we go. The red one. Yeah, I don't know what one she has. And then I know the yeah. Yeah, okay. So, I'm sorry. Where is sheesh? Oh, okay, sorry. Yes. Okay, good. I did answer it. Good. The most interesting person in the room who can use the All right. No, not that I need to know, but some of the kids, yeah, I know some of the kids, and that's the funny thing, right? Like, I know a lot of the kids on TikTok are like, what's the point? It's okay. Keep moving on. All right. So, again, we're going to do the add-in. When we do 6, right, we have 2. We're going to only move the 2 beads. Thank you, Sheesh, for letting me know. Yes, it was only supposed to be the 2 beads. And what we're doing is we're remembering the add-in. We only want to be able to do the add-in. Thank you so much for the share. So here is 3, and again, I have my abacus. I'm going to add the 5. When I add the 5, I only want to add 3. 3 is my add-in. Do we have enough? Yes, we do. We have enough to add the 3, right? So we add the 3. When we want to subtract, we can subtract. We minus the 3. We take it away from the horizontal bar. So hopefully that's enough, right? To see the difference between adding a 3 and taking away the 3. We're understanding how to do this. And again, we're big people. We know how to do it. But when we start talking to children about it, this is one of the concepts that they don't understand, is how to take away. Why is that a problem? It's a problem because what we're doing is in mainstream math, we're giving them numbers, right? We give them the numbers and we're hoping that they understand. So, so here is 5. When we add the 5, whoa, that's not 5. We have the 5 and we add the 4. We only want to add the 4 beads. We could do 1, 2, 3, 4, but we're big people. So we'll take this whole thing and we'll just move the whole thing up. And that's 4. So now we have 9. Does that make sense? So when we look, again, because we know how to add, we will know how to subtract. If I have 3, I'm going to have my abacus. And I have 3. What I'm going to do is I'm going to take away the 2. I'm going to take away these 2 beads. Does that only go up to 7? No. Sheesh, no. So it goes up to 9 because it's 5, 6, 7, 8, 9. It only goes up to 9 because just like how we write, right? How do we write 9? Right? After 9, what's after 9? After 9 is what? 10. Well, guess what? 10 is a 1 and a 0. It's 2 digits. So here, 2 digits, 2 columns, 1 and a 0. Does that make sense? Sheesh. That's a funny name. Does that make sense? Oh, hey, Ethan. Good evening, Ethan. Good evening. Cool. What are we doing? Yeah? So you don't... Oh, you can. You can. So this would be 55. Right, Ethan? It's so late. Yesterday, oh my God, people were on. We did some midnight math. So, sheesh, this would be 55. You could do 5, 5, 5, right? It could be like that. 0.55. Does that make sense? So we could do 9. We could do 9. 9. That'd be 9. Oh yeah, yes. The top bead is always the top bead will always be the value of 5. So we do 9. This is all 9. It'll be 99, 999.99. How do I know? Because I'm choosing this one as my ones place. Because this is my ones, I'm doing this. So I have my decimal sits between the ones and the tenths. Yeah? Cool? Cool. Thank you for the question. That's fantastic. I'm happy. I'm happy I don't put people to sleep. Do you understand the place value? Oh yeah, Ethan's been with me for a while. I have some regulars. So, he's waiting for multiplication and division. That's what he's waiting for. But it always depends on the class. So we have the -2. When we minus the 2, we're going to minus the 3. When we minus the 3, we have 4. We have 4. We're going to have 4, and we take away the 3. Notice what I'm going to do is I'm going to take away the 3 beads, and that's all I'm doing. So I have the 1. My answer is 1. When we look, right, we want to take away. And that was the one thing. It's interesting. So in Abacus, you know how to add. You know how to subtract. Why? Because we're now, thank you for the heart meats. So what we're doing is we're understanding how to, I will never, you will, no, Beal, you will like division because it makes it so easy. There's just a few things and a few process, but it's pretty fun. So it's interesting because in the Abacus world, we can show you how to add and the subtract is exactly the same. Not exactly the same, it's the opposite. But in mainstream math, they give you all these different ways to do subtraction, which I don't, okay. Which it is what it is. So again, here we're going to add the 5. When we add the 5, that's all we're doing. We're adding the 5. When we add the 5, right, we want to add the 1. Notice now my final answer is 6. I have 3, right? I have 3, and then I want to add the 5. Now I have 8. I'm still bending my brain, but I'm intrigued. Why? Is your frontal lobe expanding? We're making new wrinkles in your brain. So when we look at it, right, we have 1, 2, 3, 4, and then 5. 5.
Welcome to the real world.
Beal just wants a big brain. Yeah, that's what I did. I put my notes as big brain notes. Abacus division. I don't understand why teacher want. Yes, I know, right? I don't understand why teachers said, what's the half of this number? I know! It makes me mad. There was one I was watching, and they were doing a whole, like, division, like 25 times, 25 divided by, I don't know, 600, right? And they started going through 25, 50, 75, 100. I'm like, that is way too much. Anyways, what we're doing is we're looking at how to move the beads. So again, we're doing 6. When we add the 6, it's these 2 beads to add the 6. So if I have 2, if I have 1, I want to add the 6, I'm moving these 2 beads. If I want to subtract, I'm moving it away, right? So when I have 7 and I subtract 6, I move it away like this. So what we're doing is we're taking away. We add it, we take away. You notice that there's a number pattern. There's a pattern right here. To add the 6 is 1 bead on top, 1 bead on the bottom. To take away the 6, it's 1 bead on top, 1 bead on the bottom. Yeah? So we have 7, we can do 7. 7's easy, because I know how to do 6, I know how to do 7. I just need to add 1 more bead. So you notice that there's a pattern, right? We can see what we're doing. We have 8, we want to take away 7. I'm just moving 7. So it's 1 bead on top and 2 beads on the bottom. I'm taking away 7. It's again, if I had 9 and I have 8, I want to take away 8. I'm going to move 1 bead on top and 3 beads on the bottom. So when we add the 8, we take away the 8. We're okay? We understand how we're doing? Make sense? Woo! All right. So, well, what happens when there's not enough beads? This is where we start talking about how to make a 5. I don't know if anybody else knows. Oh, if anybody's interested, that book is available here. And my name is Lynette. I'm ready for division. My name is Lynette. I've been teaching Abacus for 20 years. I have 3 boys, and they all know Abacus. Do they know it in their brain? No, they don't know. Truth be told, they don't know it in their brain. But it is very helpful if they choose to use Abacus to do multiplication, division, adding, and subtracting. I don't push putting it in their brain. But that's what this is. So I'm still building out my TikTok shop. It is available here. And I'm still waiting for this. So this one is for preschool. Can I do calculus on this? I don't know. Frank, are you doing subs now? No, not yet. No, I'm not doing subs. I'm just trying to get the word out. Frank, calculus is above my pay grade. I only know adding, subtracting, multiplication, and division. Okay, so what happens when there's not enough? What kind of question is that? We can just do it in our head. Yes, you can. Yes, you can. However, oh, here it is. You can do it in your head, but then this class is not for you because you can do everything in your head. You know what I mean? Like, why voluntarily come to my class if you can do it all in your head? What's the point of coming to my class, to my room, if you can use a calculator? I should get this for my niece. Good morning. Hey, good morning, Ash. I hope you have a good ride. I hope you too. You too. Thank you for letting me know. Thank you for the comment. Yeah. Oh, but sheesh, before you go, we got to talk about this. This is how to make a 5. Why are we going to learn how to make a 5? Because we're going to go higher, right? What we did is we did simple abacus. We did simple adding, which is, do we have enough beads? Yes, we have enough beads. The question is what happens when we don't have enough beads? This is where we utilize this formula. This is a number sentence. This number sentence, I have ADHD. If I do anything in my head, I won't get anything done, right? Yeah. So the abacus helps you track it. So interesting thing is, we're teaching kids this. I don't know why we're teaching it. Does somebody tell me why we're teaching kids how to plus a 5? Why do we need to learn how to plus the 5? I don't know. I'm just trying to figure it out. But in Abacus world, we actually level it up. What we're going to do, oh, that's what I was going to do. I was going to add in a Pokemon evolve. Who is it? Charmander evolves into... Doesn't Charmander evolve into a Charizard? What? Yeah, right? So what we're going to do is we're going to evolve. We're going to evolve this. Oh, Charizard, right? Is it Charizard? Okay. Charmander evolves into Charizard. That's what we're going to do with this. So we have our Charmander, right? This is our Charmander. What we're going to do is we're going to modify it. Why? Why are we going to do it? Because if you notice, my question is, let's do a question. Let's do a question because it's always easy to see when we have a question. So here's my question. Easy. 3 plus 4. I already know what 3 plus 4 is. Yes, yes, yes. Good. I'm happy you know. However, in the abacus world, we're going to modify, right? What we're going to do is we're going to...
You need modification! Modify!
What does that mean? Remember, we have our formula. We have our number sentence. We have this number sentence. What we're going to do is we're going to utilize this top bead. When we utilize this top bead, why? Because I have 3. I want to add the 4. This is the 4. I can't add because I don't have any more beads. So what's going to happen is I know how to trade. I know how to balance. I know how to modify. So what I'm going to do, Charmander, oh, Charmeleon, and then Charizard. Okay, I'll have to figure that one out. I don't know Pokemon, obviously. So maybe I do Chameleon and then Charizard. I'd have to find that. So what we're going to do is we're going to evolve this. We're going to modify it. When we modify it, right, we're going to have this, and we're going to make it equal. We're going to isolate the variable. When we isolate the variable, it's this. But this is too much. I'm going to let that sub. Okay, this is too much. I only know so much. So what's going to happen is this is not a balanced equation. I need to balance the equation. I need to minus the 1. So when I minus the 1, right, now it's balanced, right? 5 minus 1 is equal to 4. Now what are we going to do is we're going to substitute it. When we substitute it, this is directions on how to use the abacus. We want to add the 5 and take away the 1. So my final answer is 7. We are not memorizing doubles. What we're memorizing is we're understanding this concept. You could do a power-up sound. Oh, yeah, power-up sound. Okay, that's a good one. I could do a power-up sound. Oh, that'd be good. That would be good. I've been trying to figure out how to do this. But yeah, power-up. That's a good one. I like that one. I'll have to remember. All right, does that make sense? Let's do another one. I don't know. That's kind of wonky. So if you notice, the abacus is kind of cool because it provides restrictions. And because it provides restrictions, then we have to use different ways to modify, right? Different ways to critically think on how to do things, right? We are given scenarios to do many, many things. Okay, so if I have 4, I want to add another 4. I don't have enough beads to add the 4. But wait, I know how to plus the 4. I want to add the 4. All I need to do is plus the 5 minus the 1. So I add the 5 and I take away the 1. So my final answer is 8. Let's do it with money. Money, 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 money. So if I have 4, right? I have 4. I need to add another 4. To add another 4, I only have a nickel. A nickel is worth 5 cents. This is 4 cents, right? That's crazy that you can add, you have to subtract. Oh, yeah, yeah. So I have this, but it's not. It's also balancing, right? Because I'm giving you too much. If I give you this 5 cents, it's too much. So it's like trading. It's like change. What we're doing is we're changing. Where I'm going to give you 5 cents. I give you 5 cents, but I've given you too much. So I have to take away 1 penny, 1 cent. So now you have 8. Oh, see you later, Bill. Yeah, I hope you have a good day too. I'm happy you enjoy your work. Yeah, it's like carrying on. Yeah, I like math. Great. Math is hard. Great. Thank you. All right. It is very money coded. Yes. Right? Makes sense now, right? So what we're doing is we're understanding that if I have this, it's the same thing. If I have 3 and I only have a nickel, right? Yeah, Papa Cap, not a problem. I want to add 4, but I don't have enough. I only have a nickel. I only have 5 cents. So I'm going to give you my nickel. I'm going to take away the 1. So then what happens? My final answer is 7. So if I had 3, I have 4 plus the 5 minus the 1. So you'll see if I need to subtract, right? Does that make sense? So we could do it again. If I have 2, I'm going to give you 4. Do I have enough beads to add the 4? No, I don't. What do? I'm going to give you my nickel. But I'm adding 4. This is too much. I'm going to give you my nickel. I'm going to give you my 5 cents. I'm going to give you my 5 cents. But that's too much. I need my change back. So my final answer is 6. Does that make sense? So here's my question, right? 4. So I have 4. And then I want to add another 4. I'm going to substitute plus the 5 minus the 1. And this is what it looks like. Plus the 5 minus the 1. And then my final answer is 8. How are we doing? Make sense? How's it going? Right? We're all right? So this is when we don't have enough. We can do it again. We can do it with the 3. When we do it with the 3, it's the same thing. What? What do you mean it's the same thing? It is. The concept is the same. Miss going to school. This live makes me feel like I'm back in school. I don't know if that... Oh, because you missed it. Yeah. So let's do 3. Let's do 4. We do 4? Right? I'll do 4. Let me do 4. I want to add 3. But that's too much. I only have a nickel. I only have 5 cents. I know this. I'm going to isolate the variable 3. And I'm going to be able to make it into a 5. So what's going to happen? I'm going to give you my nickel, but that's too much, right? I'm going to take away 2. So my final answer is 7. How are we doing? Oh, right. So anybody's interested, it is this book right here. Right? I hear dogs barking. Yeah, that's my dog. My dog. She's barking at other dogs. So here is another way I explained it. Right? Here is we have 5 cats. So if I have 3, and I want to add another 3, I'm not going to memorize, right? I'm not going to memorize doubles. What I'm going to do is I'm going to understand my formula. So notice I have to go to 5 cats. There's 5 cats in the tree. I go to the 5 cats in the tree, right? But then 2 cats run away. You know what? In class they used to write the equation like that. Backwards, left, but never explain why. Yeah, I don't know why either. I don't know why. That's the question. My big question is, why are we teaching the kids how to make a 5? I understand why we make a 10. And I'll get into that on the abacus. But in the beginning, like, I don't understand why we're teaching the kids how to make a 5. But in abacus, we're going to do a power up, right? We're going to make it and we're going to utilize it. So you'll see, right? It's very versatile. So we go to the 5 cats in the tree. There's always going to be 5 cats in the tree. You go to the cats in the tree. I go to the cats in the tree. But then too much, right? So that's why this is. And so what I did was I was trying to make it understand, make the kids understand. So here's another one, right? If I have 4 and I need to take away the 2. I'm sorry, I need to add the 2. When I add the 2, I know plus the 2 is equal to plus the 5 minus the 3, right? That is the formula. That is the pair. The pair is the 3. So when we look, I go to the cats in the tree, I grab 2 cats, but 3 cats run away. So 3 cats run away. My final answer is 6. Yeah. Right? Cool. How are we doing? Make sense? Oh. Oh. Cool. Okay. Okay. So we did that. We did 1. We can do 1. 1 doesn't have a very many, it's not utilized. There's only 1 question for 1. And it's exactly what you see. If I have 4 and I need to add the 1, to add the 1, I'm just going to plus the 5 minus the 4. That's the only question you have, right? So if we had 49 and we need to add the 1, we need to plus the 10. Oh, I should do that later. All right, we'll do that later. But 1 is very powerful because it carries over to here. Okay, so that's how we add. We can do subtraction. Are we ready for subtraction? When we subtract, we're taking away the 5. How are we doing? We're all right? We're going to take away the 5. Are we ready to take away the 5? Same thing. If you notice, so this is adding the 5. We need to understand how to minus the 5. When we minus the 5, it's the opposite. So if I have 8, and I want to take away the 4. Take away the 4. What? Well, we know how to add the 4. When we know how to add the 4, we know how to take away the 4, right? Take away the 4 is what? Minus the 4 is equal to minus the 5. Minus the 4 is equal to minus the 5 plus the 1. Yes! Yes! Right? But what are we going to do? We're going to, exactly, minus the 5 plus the 1. And my final answer is 4. Make sense? Yeah, because we know how to add it, we know how to subtract. Yeah! Yo! Well done. Well done. We can do it again. We can do it again. If I have 7, this is 7, and I want to take away 4, minus the 5 plus the 1. My final answer is 3. So what are we doing? We're practicing and understanding the concepts. We're compounding our information. So because we're starting to learn how to do this, right? Then we can take it to the next step. We can take it one step further. What's the one step further? Well, let me find my question. Now we know the basics, we can start going into bigger numbers. It can now be scalable. So here's a big number. I'm going to put in this number. 1, 3, 5, 7, 8. Right? I'm going to add 2. Do I have enough beads to add the 2? Yes, I'm going to add 2. Is there enough to add the 4? We know how to add the 4. How do we add the 4? We add the 4. Is there enough beads to add the 4? No, there isn't. What can we do to add the 4? Plus the 4 is what? Plus the 5. Yes, Ethan, thank you. Plus the 5 minus the 1. Is there enough to plus the 3? Yes, we can. I'm going to add the 3. Is there enough to add the 1? Yes, add the 1 and add the 1. So my final answer is 37,889. So notice that it's very scalable. It doesn't matter now. When you know the basics and the fundamentals, you'll be able to do more than just anything. You'll be able to scale it. Does that make sense? Sheesh. Fire!
Welcome to the real world.
Right? So we don't need to worry about how to make this friendly. Yeesh. Oh, I've been trying to do it, but I got it wrong. Okay, let's do that. Let's do it. Okay, let's see what Ethan has given me. Eight, 5, 7, 5 minus 1, 8, 5, 6. I don't know what we're gonna do. 8, 5, 7, 5. Right? Is there enough to take away the 1? Yes, take away the 1. Oh, I know why. Because this is a 2-step. That's why. How do we minus the 8? Minus 8 is equal to plus 2 minus 10. No, that's not right. So minus the 10 plus the 2. Oops. Minus the 5 minus the 6. Minus 6. Minus 6 is what? Plus 4 minus 10. Plus the 4 minus the 10. I don't know what happened. So my answer is 6, 7, 1, 9. Is that what you get? Did I do it wrong? Did I do it wrong? Excuse me. 5, 7, 5, take away 1, 8, 5, 6. How are you getting it? What was your answer, Ethan? That's right. Thank you. Ethan, what was your answer? You're right. Thank you, Jazz. That was easy. That was easy. There wasn't very many things. Let's do it again. Let's do it again. So we do 8, 8, 5, 6, 7, 8, 5, 7, 5, 6, 7, 2. Okay. Okay, here. Let me see. Let's see. Let's decompose this. 29. Okay. 7, 5, 5. So I did this. I did 1, take away 1, take away 8, right? Take away 8 is minus the 10, plus the 2, minus the 10. I'm going to plus the 2, minus the 10. So then I'm here. Then I'm here. I want to... Oh, I see. So that's what you did, right? Minus the 5, which is fine. It's this one right here that you're getting stuck on. It's the 6. Minus the 6. You cannot forget it. Explain the minus. Yes, I will. Ethan, don't forget this minus 10. You're forgetting this minus 10. Yes, that's the next step. So we want to plus the 4 and then take away the 10. Ethan, are you there? So that's what happened. It's because you forgot this one right here. So that's why it's always good to figure out. I think that's the reason. Thanks. Yeah. Right? It's always good to figure out why we get it wrong. Okay. So, yes. Thank you, Sheesh. What's going to happen is we're going to understand how to make a 10. Right? We understand that we made a 5. Right? We understand how to make a 5. Now we're going to go to is we're going to understand how to make a 10. So, thank you, Ethan, for this. What happens is... Oh, I guess so. I guess we won't do this one. We'll do next time. All right. Make a 10. Make a 10. Excuse me. I think I did it wrong because I was doing it too fast. Yeah, you know, speed... Sometimes speed is, I think, is overrated. You know, like Albert Einstein, he took a long time to do math. I don't know why we're trying to push all the kids to do it so fast. Okay, so Sheesh, thank you for your comment. We are going to learn how to make a 10. Why are we going to learn to make a 10? Because it's easy and we need to do carrying on. Why are we going to understand it is because let's say we have 8, right? So here's my question, 8. 7, I want to add the 8. Notice I don't have enough beads to add the 8. We know our pairs, 8 and 2. 8 and 2 is our pair. When we look at it, what we need to do is isolate the variable. When we isolate the variable, we're going to isolate the 8. Plus 8 is equal to plus the 10 minus the 2. So now, if you look, I'm going to carry on. Plus the 10, because remember, and then minus the 2. How do I know what 10 is? Remember, hello, hey, yo, welcome back. So remember, this is 9. When we make a 10, it's a 0 and a 1. That's what 10 means. Add a 10. So what we're doing is we're just going to add this one bead. So if I have 7, I want to plus the 10 minus the 2 to add the 8. Plus the 10 minus the 2. So my final answer is 15. Does that make sense? Sheesh. Does that make sense? Okay, facts. Right? We can do it again. Let's do it again. Let's do it again. We do 4. We do 4. We plus the 8. Not enough to plus the 8. We know plus the 8 is equal to plus the 10 minus the 2. Plus the 10, right? 1, 0. And then take away the 2. My final answer is 12. Yeah? How are we doing? We're all right? Easy, right? there's a whole slew of, these are all the pairs we have. We could do it all. So we had Ethan's question. Yeah, not bad. I'm telling you. So we had Ethan's question. This is a subtraction. Same thing, but opposite. So let's do it again. We do 8, 5, 7, 5, right? We want to minus the 1. Can we take away the 1? Yes, we can take away the 1. Now we need to take away the 8. When we take away the 8, can we take away the 8? No, we can't. We need to use this formula. Minus the 8 is plus the 2 minus the 10. Plus the 2 and then minus the 10. Notice I'm going to minus the 10, minus the 1, minus the 10, 0, 1. I'm going to minus the 10. Then I'm going to take away the 5, right? And then I'm going to minus the 6. When I minus the 6, what do? Is there enough? No, I cannot minus the 6. What do? I know my formula. See how these two are a pair? This pair makes a 10. So minus the 6 is equal to plus the 4 minus the 10. Plus the 4 and then minus the 10. This is where he went wrong and he forgot to minus the 10. So my final answer is 6,719. Oh, yo! I did the division yesterday. I don't know if you were there for that. Okay. Okay, how are we doing? Anybody have any questions? Yeah, not bad. Cool. Make sense? Excuse me. All right, how are we doing? We're all right? Anybody have any questions? So we can, let's do a little review because there's a few people that joined in. Let's do a review. So here is my abacus. This is a counting tool. This is a math counting tool. This counting tool just helps me keep track of my numbers. That's all it does. Can you do multiplication? Yes, we can. Let me finish this. So we go 1, 2, 3, 4. Anytime the beads are touching this horizontal bar is counted. So then we do 5, 6, 7, 8, 9. And then we have 10. How do we do it? Is that all right? 11, 12, 13, 14, and then 15. All the top bead is a value of 5. Ari wants to do multiplication. Are you ready for multiplication? Hey, multiplication. Ethan, do you have a multiplication question? Okay, let's do it. Let's do it. Okay. If we're okay, then I'm going to continue on with multiplication. How are we doing? We're all right? Yeah? Cool? Okay. Multiplication. Multiplication. It's easy. Oh, sheesh. We don't do negatives. So if I did it, it'd be 20 minus 16. Right? So 20 looks like this. 20 looks like that. Take away 16. Take away 1. I'm sorry. Take away 1. Oh, I meant 16 through 20. Oh, I see. So 15, 16, 17, 18, 19, 19, and then 20. 21, 22, 23, 24, 25. That's it. There's nothing special to it. Yeah. There's nothing special to it because we're just counting. So the idea of counting is just making sure that we do just one by one. But this 5 is what kind of throws into a little loop. So we have 5, 25, 26, 27, 28, 29. So if we did 9, right? 9, 9, 9, 9, 9, 9. Make sense? So, Kyle, yeah? How are we doing? Why didn't we start in the other? Oh, hey, that's a good question. Because this is my ones, my label. This is my ones label. And my ones label, just like a Pokemon.
Pokemon, I choose you!
I choose this one. I have another one. If you notice, I have 2. On this abacus, I have 2 indicators, 2 labels. I have to choose one. So this one I choose. So this one, so when we look, Ones, tens, hundred, thousands, 10,000. When I have it, if I choose this one, I'd move everything over. How do you... So when I choose this one, ones, tens, notice I don't have any beads for the hundreds. I don't have any beads for the hundreds, so that's why I choose this one over here. Make sense, Kylie? How are you doing your screen like this? What, with me in it? Oh, and then, I'm sorry, before I forget, Kylie, you can also do the decimals, right? So here's my ones, my decimal sits between the tenths and the hundreds. So this is like money, like change. We have our 15 cents, 1, 5. Yeah? So when we look, what's the maximum number you can make on this? On this specific one is not very high. It's only 7 columns. So if you look, it only has to 10,000. So I have 99,999.99. Now, if I wanted to, I could use a larger abacus, right? Like this. This is my bigger number because what? Size matters. This is 13 columns. 13 just means 13 digits. So if I choose this to be my ones, I have my ones, my thousands, my millions, my billions, my trillions. Make sense? So it doesn't matter what dot, it doesn't matter what the ones indicator is. It all just matters which one you want to go. You just need to choose one, just like a Pokemon. Just choose one.
Okay, Charizard, I choose you!
Make sense? Right? Or if you want to track the national debt, you could use this bigger one, which is 23 columns. It's 23 columns. And then it'll be able to track your national debt because, again, size matters. Okay. Wow. So, showing you separate in the corner and the notebook on the columns. Can you show multiplication? Oh, yeah, that's right. Thank you. So we're ready. I have 2 cameras. I have a document camera and I have a webcam. That's what I'm doing. All right. Let's do a number. Let's do 24 times that by 6. Yeah, not a problem. It took me a while to get to this understanding. So the first thing we're going to do is understand on the abacus how to multiply. Now, on the abacus world, we're going to count our digits. We're going to use our ones as our starting point. So we're going to count the amount of digits we have. 1, 2, 3. When we look at it, we have 1, 2, 3. We know we're going to start at the hundreds column of some sort. Why? Because what we're trying to do is we're trying to understand roughly where we are. Does that make sense? We could be here, we could be here, we could be here. I don't know. But we're going to start around here. We need a ballpark. Good. Thank you. So what we're going to do is understand 2 times 6 is equal to 12. Now, if you notice, I said 2 times 6 is equal to 12. I'm going to have my 1, I add 2. That's it. But in mainstream math, they don't do 2 times 6. What they do is, what do? They do 6 times 20. 6 times 20 is equal to 120. The reason why they do it is because they write it out. But in Abacus, we don't need to write it out. It tracks it for us. See, look, 120. But I just need to put 1 and a 2. That's what makes it easy. Because now it's in manageable chunks. We're not going to say 120. We're going to look at our digits. We're going to look at our columns. So what's the next number? Their next number is 4. 6 times 4 is equal to 24. So I'm just going to add the 2 and I'm going to add the 4. So my final answer is 144. 144. That's it. That's my answer. I mean, you could do the strategies, right? You could do all the strategies in the world. You could take this and divide it by 2, and then you could times this by 2, which makes it 12, and then this is 12, and you could do all of this strategy. Or Abacus, you just take it one at a time. That's it. It is easy. It is easy. That's the pattern. We only need to do it this way. This is what we call in Abacus world. I don't know in Abacus world. In algebra, it's called distributive property. This is what we call distributive property. property. I don't even know how to spell property, but that is what it is. We can do it again, right? We can do it again. We can make the numbers bigger. We'll do, I don't know, 25 times that by 73. What? That's crazy big. No, it's fine. We do it again. We count it again, right? What we're going to do, 1, 2, 3, 4. How do I know? 1, 2, 3, 4. 7 times 1. 7 times 2. 7 times 2 is 14. Add 1, add 4. 7 times 5 is 35. 7 times 5 is 35. Add 1. I'm sorry, 30, add 5. We know how to add the 3. Do we remember how to add the 3? Plus the 3 is equal to plus the 5 minus 2. Look! Right? It's exactly the same. If we want to add the 3 plus the 5 minus the 2 and then add the 5. Then what do we do? Well, we're done with our 7. Next, we count it again. 1, 2, 3. 1, 2, 3. We're going to be here. 3 times 6, 3 times 2 is equal to 6. 6 is a single digit. I go back one column, I add the 6. 6 is too much. I need to plus the 6's plus the 10 minus the 4. Plus the 10 minus the 4. Again, this is why we need to know our math facts, right? We need to minus the 4. To minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. And then what do we do? 3 times 5 is equal to 15. Add the 1, add the 5. We're done. So the only sticky thing right here was the 6. Does that make sense? But if someone didn't know the answer for the smaller multiplication problems, oh, you have to memorize that. So yeah, you're absolutely right. And that's when we start going into you need to start knowing your math facts. But if you notice, right, learning your math facts is going to be easy. You could do it this way, which is what? 6 plus 6 plus 6 plus 6. And it's good to know how to do this. Why? Because then you can be versatile. It's called number fluency, right? How could they? There's a process to it, right? Abacus is a technique. Is how I survived through elementary school. So we do this. We know that when we add the 6 and we're going to add another 6, we're going to have it, and then we add another 6, we just add the 6, so we have 18. And we add another 6, we know it's going to be plus the 10 minus the 4. Right? So that's what we're doing. So you need to know your math facts, but you could do it on the abacus. You just have to do additive addition. That's how I got all my boys to memorize their multiplication, because they got tired of doing abacus addition and it gets boring, right? So they start to memorize it. You'll start to see the patterns. When you see the patterns that this is 24, 4 times 6 is 24, you'll see it. If you don't see it, then you can say, well, if I know 4 times 6, if I don't know that 4 times 6 is 24, I know that 5 times 6 is 30. I just know this, right? I know all I need to do is minus the 6. So if I did 30 and I take away the 6, I know I'm going to do that. Does that make sense? So the big thing is to understand that you can go up and down. It just matters on how you do it. I think what in mainstream, we forget that we can actually leverage big chunks of what we remember. Right? If we remember that 5 times 5 is equal to 25 and I want to add one more or I want to add one less, right? We know we're going to take away the 5 or add the 5, right? So this is something that we forget. And I think that's the problem with mainstream math is like we want the kids to memorize their math facts, but we don't teach them how this works. How are we doing? Is that all right? So that's how you do multiplication. We could do more multiplication, but... Okay, cool. Shooting stars. How long did you learn abacus for, shooting stars? Yeah. Yeah, I have 3 boys and they all know how to do the abacus. They kind of forget sometimes, but they like it. They don't understand the benefit because they don't know what it's like to memorize. But I see the difference, and I notice that, understanding, the multiplication and division and stuff. So, yeah. Like 2 months, I think, when I was in. Wow, really? So that's very interesting. And you know how to do do you know how to do multiplication and division, or was that just adding and subtracting? I'm sorry. Now I just want to fix this because it's kind of bothering me. um, Adding and subtracting. Oh, okay. Yeah, 2 months is not a lot. But it's good that you know how to do adding and subtracting. I do recommend it. Um, and it's interesting. But yeah, you could do multiplication and division on it. How much do we use it? We don't really. I mean, after 5th grade, they start doing the calculator, which is fine. But the biggest thing is understanding, like, the biggest thing is understanding how the numbers work. Ah, I'll fix that later. All right. So, yeah, it's very interesting. And it kind of segues into algebra. There's a lot of things that we do in algebra. There's a lot of things we do in abacus world that is very similar to algebra. And so that's why we were talking about, like, how to isolate the variable, distributive property, commutative property, and so forth. So that's what this is. All right. Does anybody have any questions? If not, I mean, that's about it. I mean, I have a bunch of activities, and I have, oh, that's the other thing I want to do is I want to record that. So we have that. So let's do a real review. Let's do a review. We're going to read the abacus. We have 1, 2, 3, 4, and then 5. All the top bead has a value of 5. We have 6, 7, 8, 9. After 9, we have 10. So if we notice, every column is a place value. When we have it, let me see if I can find it. Thank you for the likes. We have our ones, our tens, our hundreds, our thousands, our 10,000. And then what's going to happen is we have our decimals. Our decimals sit between, our ones and our tens, right? That's the decimal, just like how we write it. So this is 10, and then we have 11, 12, 13, 14, and then 15, 16, 17, 18, 19, and then 20. That's how we do it. Oh, what? Like your syndrome is down, but your math is up. I don't know what that means. Sorry. I'm a simpleton. I don't know what that means. So what's going to happen is we have 220, right? 20, 2, 2, 2, 2, 2, 2, 2. Yeah? So when we have it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, and then 14, and then 15. And then we could do 20. This is what 20 looks like. 20, 30, 40, 50, 60, 70, 80, 90, 100. But your math is up. I don't know. My subprime? I don't know. I don't know what you just said. That doesn't make sense to me. I'm a simpleton. I need to get stuff translated because I don't know the new kids' terminology. All right, how are we doing? Are we all right? So what are we doing is, that's what my math book is. And if anybody's interested, it's here or my TikTok shop. I do have the abacus available. Hi, my name is Lynette. I've been teaching abacus for about 20 plus years, and now I'm making some workbooks to make it easy for the kids to understand how to use the abacus. And I'm trying to make it more enjoyable because abacus is really quite boring. Math is boring. Math is not supposed to be hard. So here we are. When we look, we have 1. So I'm going to use pennies. Pennies is worth 1 cent. 1, and then 2, and then 3, and then 4. That's what 4 looks like. I got sidetracked. I missed the division. So I'll be back later. Oh, I didn't do division. I don't do division very often. So we have 5. The top beat is 5. And then we have 6. And then we have 7. And then we have 8. And then we have 9. That's what 9 looks like. Yep. Division's a little bit more process. There's a little bit more of a process. So it would be a little bit. Thank you, Sheesh, for staying behind and talking with me. I don't know if anybody else is here, but, you know, it is time. I am going to go get some breakfast. Anybody have any questions? If not, I will see you guys all in my live. Of course, have a good day. Yes. Thank you, Sheesh, for the interaction. Thank you. No, thank you, Kylie. Did you have any questions, Kylie? Like, any other questions? Yeah, can you explain 6 divided by 3 on the abacus? I know the answer is 2. No, see, when we do it, Ethan, when we do it, we do it on the abacus. It's been fun. Oh, good, Kylie. Okay, so Ethan, on the abacus world, the way we do it is we do the missing added. We do the missing math multiplication fact. So we have to do 3 times what is equal to 6 or less. So you're going to just have to know your multiplication. Does that make sense? This is what we do for division. This is how we do all our divisions. How do we do the opposite of multiplication? Does that make sense, Ethan? What is your question? What's your dividing question? Does that make sense, Ethan? I don't know if you're still there. All right. Ethan? Thank you so much for the likes. Frank? Where are you, Ethan? Okay. Okay. Ethan? I'm just waiting. Okay. I'm going to log off. I'm going to sign off. Thank you guys for joining. Ethan, let me know what you're talking about, because I'm not sure. Oh, okay, okay. There you are. So if it's 6 divided by... Yes, that's how I would do it. So if it's 6 divided by 3, it's 3 times blank equals 6. Yes, that's how I would do it. That's how I would do it. Exactly, exactly. So this would be... And that's what they call about number fluency, right? 6 divided by 3 is equal to blank. Yeah. So this is that. So reverse them in the times table. Yes. Yes, because we don't have a division table, if you noticed, right? We don't have a division table. Division table. We only tell the kids that there's a times table. It's always easier to understand, right, how to add than to subtract. It's always easier to understand how to divide than to times than to divide. So when we do it in the abacus, oh yeah, right? So that's the difference. It is the reverse times table. Yeah. That's a very good question. Yeah, you're welcome. And so we always tell the kids, right? What is this? We don't tell them how to divide. It's harder to see division than it is to see multiplication. All right, cool. Was there any other questions, Ethan? I know it's very late for you. We're okay? Division table, more like the vision table. Yeah. Okay. Okay. Okay, Ethan, I will see you in my next live. Thank you, everybody for joining. Thank you, everybody, for joining. And have a good day. See you guys later. Bye.